So good evening. Thank you so much again, once again joining in. And today we are going to discuss, one case. Basically, the idea is that I'll give you a case which is a bit more, latest in nature, which is being solved by the industry right now. And with that, we'll also see one predictable way to approach any case study, right? So today case is actually based on a very large, this is a real case. I've just made it fictitious so that we can discuss it. But the case is around designing circular supply chain for a global consumer electronics firm. Later on, once we get the solution, I'll also reveal the name of this company and who did this case, which consulting firm did this case with them, right? That also we'll discuss. To start with, let's get directly to to jump to the case topic. So the case is something like that there is a global electronic company, right? A consumer electronic company which makes devices like smartphone and laptops, and it depends heavily on aluminum, copper, and rare earth elements for its production of the smartphones and laptops. By the way, these materials are also used in some other industries like electric vehicle and batteries and so on and so forth. However, producing these materials is highly carbon intensive, which contributes significantly to global emissions. Okay. So they use aluminum. This is a global electronics company which makes devices like smartphone and laptops, and they depend heavily on aluminum, copper, and rare earth metal. And producing these materials is highly carbon intensive, which contributes significantly to global emission. I think the data is almost 20%. 20% of the emissions are, contributed by these materials on the environment. While demand is rising, right? All the consumer electronics like smartphone, laptop demand is rising, and mining supply faces environmental, geopolitical, and capacity constraint. You know that also, right? That there's a constraint of copper, aluminum, and there are a lot of talk is going on around rare earth elements. Now, company has come with a solution to deal with this for long term. What they want to do, they want to increase the use of recycled material, right? And reduce their vendors' supply chain emission. Okay, so that's the idea. So they want to recycle it. Okay. Now they have brought in you. So you are the consultant, and they have brought in you to determine one, where this additional recycled supply can be sourced from, which materials should be prioritized. Should we prioritize aluminum? Should we prioritize copper? Should we prioritize RE, rare earth elements? And how do we approach? How do we come to that decision? What should we do? Okay, so that's the case is given to you. And as I said, this is a real case. I'm just changing the specifics of the case, which is, again, inspired by a case which is done by McKinsey to a company, and which I reveal it later after this case. Okay, so that's the case. Now, the idea for any case study which is given to you is not to bog down by too much details, not to get scared by the terminology which is used. Whatever you don't understand, if you don't understand what is aluminum, copper, ask that also. If you don't understand this, whatever you don't understand, while some general knowledge is good to have, and for that I would recommend to read more, so that at least the obvious thing you should not ask. But still, if you don't know, you don't know. You can ask the clarifying question. There is a predictable way, or there is a way which recruiter asks or expect you to approach these kind of cases, or any case for that matter. That approach, as you might know from my previous session, is clarify, set the objective, structure, analyze, and recommend. Let's see this in action while solving this case. Okay. So I hope you got the case. The case is there's a consumer electronics companies which want to rely more on recycled material, right? And for that, they want your opinion to where do we get these recycled material, which material to be prioritized, and which actions are required to unlock this circular material. So that's the idea. So start with clarifying questions. So never ever jump to solution or approach. First, check have you understood the problem clearly? Ask some clarifying question. Some of the good clarifying question could, okay, before that, paraphrase the understanding. I mean, just whatever you listened, just paraphrase it. If I understand you correctly, this is what you have said. And have I understood or have I heard the problem correctly? That is the first step you do. Now, second, you ask clarifying question. So some of the very good clarifying question could be this. How is the client defining success? Is there target percentage for recycled content or a specific emission reduction goal? So what is their ultimate objective? Do they want to increase the uses or the percentage of uses of recycled content, or do they want to get into a specific emission reduction goal, or do you have any other objective in mind, primary objective in mind to do all these things? Why are we doing this? Right? It's a question you should ask. It's a very good clarifying question. Are we focusing on all products and materials, or should we prioritize specific product lines or materials like aluminum, copper, or rare earth? Which one should we prioritize? Is there any where is client operating globally, right? Or which region where there is supply chain or recycling concept are more critical? I mean, which region are we operating? Which region we should definitely prioritize? Which regions are more critical in terms of they are not getting the material, or where we have to recycle because of environmental laws or whatever, right? Also, is there any constraint which we should be aware of? These are some of the good clarifying questions you should ask. Some of the bad clarifying question you should not ask is, what industry is client in? It is already given in the case. Can you tell me more about this company? This is a very broad question. You should not ask like this. Should the company just invest in recycling plant? I mean, that's the solution, right? That will come later. Should not directly jump to solution. What's the company market share in smartphone? Again, irrelevant question. Why don't they just stop using these materials? That's again very irrelevant, very novice kind of a question. Is recycling good for environment? Again, a very broad question and very high level question. It's not so relevant for this case. So you should avoid these kind of questions. You should be very focused. Why are we doing it? Is there any percentage target for recycling or per percent target for emission reduction? What kind of product should we focus? What kind of geography should we focus? These kind of some pointed questions, clarifying question could be good to ask. After that, let's say clarify, given that you can focus on copper, aluminum, and rare earth metal. Let's say they give some clarification once you ask this clarification question. You may get, you may not get, you may say, the recruiter may say, ki, boss, you assume whatever you want to assume and go ahead with that. That could also be one of the case. So don't, again, bog down by all these things. Now, in the next step is, after clarification, set the objective. Have a consensus, have a, ask a recruiter or interviewer that what exactly is expected from you. Just paraphrase that. Just confirm that with the recruiter so that you involve recruiter also in, and maybe you engage him also or her also, that this is what I need from this candidate, right? So you ask something like that. Okay, just to confirm, is my objective to recommend how the client can increase the use of recycled material in its products while ensuring supply security and managing cost and emission trade-offs? Is there any other objective also? Or do you want me to do this? What exactly do you want me to focus? Right? Something like that. So that you know what is expected for you. So ultimately, for example, client want you to increase the recycled material in its product while considering these factors: supply constraints, managing cost constraints, and emission trade-offs. I mean, you should reduce the emission, you should reduce the cost. Ideally, you should reduce the emission, you should reduce the cost, and you should use more recycled material in its product. So that's the objective, right? So you just confirm that, and then maybe recruiter may give you a better objective or clearer objective which you need to do. Okay, I don't want anything else. Just tell me, for example, just tell me where we can use recycled material. How will you find out that? I mean, it could be as simple as this. You don't have to overcomplicate it, right? So basically, set the objective with the recruiter. The third is structure. Now, here is my question to you guys. What structure, what framework, what 3 to 4 factors would you consider to analyze or to find out where this consumer electronics company can use or should use recycled material? I'm repeating my question. What is that framework would you like to design? And when I say framework, it's not a ready-made framework. You have to evolve from a first principle thinking, from your common sense. What are 3 to 4 to 5 to 6 factors would you look at to decide which material should you recycle, which material should you not recycle, Which material should you recycle with some constant? How do you find out that? What are 3 to 5 factors? Anyone? Anyone wants to pitch in? Okay. So let's see. There are 4 to 5 factors which you should look at to decide where to recycle, what not to recycle, and what are those factors, what are those buckets. Let's look at those buckets first. So let's say those buckets are demand side. Where can recycled material be used? Where are the demand of which kind of material? Supply side. Where will we get these recycled material from? Economics. Will it make financial sense? Sustainability and strategic value. Why should we do it beyond cost? Or will it help us reducing the emissions or enable us? How do we do it? What must company do to unlock this idea of recycled material? So these are the 5 6 buckets which you should consider to decide which material, what products, right? What area you should invest on, and what are the factors you should look at: demand side, supply side, economics, sustainability, and strategic value. Basically, how much carbon dioxide you're reducing, the emissions reducing, and enablers, like actions, what you should do, kind of to make things possible, right? So let's see. Demand side, you should know which materials are critical. Critical in the sense in terms of functioning of the product: aluminum, copper, rare earth metal elements. What are the some of the quality and performance constraint? Like what is the minimum, let's say, specification of aluminum, copper, or REs you should definitely have? What are the design limitations? Like we cannot use certain amount of alloy or certain amount of purity. Beyond certain amount of purity, we can't use it. Right? These are some of the product requirements. Volume outlook. What is the production growth by product line? And hence, how much aluminum, copper, and REs would be required in future? And what is the material intensity per device? And hence, the volume outlook. Substitute potential. How much? How can recycled material fully replace the virgin material? Or what is the blending option? How much percentage can we go and blend this? These are some of the questions we would like to consider from demand side. From supply side, where this recycled material comes from. So these are some of the areas, and this is very important thing. What are the scrap sources? For the recycled material, we have to use scrap. Now, scrap has 2 sides: pre-consumption side and post-consumption side. Pre-consumption side is manufacturing side. Whatever waste you are incurring during the manufacturing process is your pre-consumer scrap. Can we use it to recycle the material? How much is that? Post-consumer scrap, end of life devices and other industries. Where we will get this data? How much material will be available after this? How will you collect that? Right? How will you collect that? The collection and access. How will you collect that? E-waste system or take back program or geographic concentration of scrap. How will you collect that? And do you have processing capacity? How would you sort it? You need to really sort maybe at a micro level. Let's say there's a mobile. You need to open it up. You need to maybe take out battery and put it somewhere. You need to put some other content somewhere and maybe extract ultimately this fundamental aluminum, copper, and REs for doing that. Right? How do you sort that? Do you have recycling capacity and capability? Not just capacity, but capability and capacity. Capability means technology. Capability means capacity. And what is the yield? Let's say you use 1 ton of scrap material. How much you can actually get the virgin or the material which you need, right? So these are some of the supply side issues which you need to consider. Economic side, cost comparison. How much will be the difference in cost between the recycled material and the virgin material cost? What will be the processing cost, logistics cost, all other costs? Maybe ultimately, what is the difference of recycled material cost to a product versus virgin material cost to a product? How much investment is needed in different facilities, in R&D, in manufacturing facility, in recycling facilities? And what is the risk which you should consider for future commodity prices? What is the long-term supply stability of this material? Let's say a material is abundantly available in future also. You may not want to do, at least from the supply constraint perspective, you may not want to do recycling. But let's say we talk about a rare earth element which is difficult to get by these days. You might want to consider that risk and hence recycle some of the materials if possible. So these are some of the economics you need to consider. Sustainability: how much carbon oxide or CO2 saving you will be having versus if you don't use it. How much sustainability in the emission sense, sustainability in the supply sense. How much security we will have of these material, supply security will have this material of these materials if you use these recycled material. And how will your brand look, how will your ESG positioning will happen, how consumer will like your product because it is based on recycled material. Will it give you a brand value, will it give you some leeway, some compliance with the upcoming regulations or tighter regulations. All those things you need to consider before. So cost is not just one element. You need to also consider future sustainability and strategic value of the recycling in the coming years. And last but not the least, how do you do it? How do you design in such a way that you can disassemble things easily and hence extract the recyclable material? How do you simplify the material so that you don't have multiple material mix and it is very difficult to extract? How do you do partnership with recycler, other OEMs so that you can aggregate the demand? Maybe you need small amount of some material, but when you aggregate amongst the other OEMs, other consumer electronics product, you will have a large demand of these things, and which will be make sense for someone to recycle these materials. How do you do partnership with governments, long-term agreements, some green premiums, industry alliances, right? Something, right? You should consider all those things before deciding the thing. So basically, you kind of analyze qualitatively what are the factors should you look at, and this is what you're kind of some of them. If you don't know a lot of these things, at least you should know demand side, supply side, and cost side, and carbon dioxide saving. At least this much you should know. And anyways, this will be there. You can also review it. This deck you will review it in the YouTube. So these are some of the areas which you should look at. So till now, what you have done in this case, you have asked a clarifying question. You have set the objective. You have set a framework or a structure to analyze this problem, to call out the buckets or the areas which you should analyze before deciding upon. Till here, what recruiter is doing, he or she is looking at or evaluating your structuring techniques, your clarification techniques, your thinking under the ambiguity things during ambiguity, right? Now he or she may want to give you some data to see how will you analyze data, how will you analyze, how will you calculate, how will you make sense of the given facts or data. So let's see some data. So let's say this is the data given. This is a fictitious data. It is nothing to do with the actual case. I've just made it up just for the purpose of calculations, right? So let's say this is the data given to you, right? Like material, aluminum, copper, REEs, annual use in client products, 2 lakh ton, 120 lakh ton, 120,000 ton, 5,000 ton. Maximum additional recycled capacity available. How much maximum you can recycle? 80,000, 40,000, and 500. How much is the carbon dioxide saving as compared to virgin if you use virgin material? So 9 tons carbon dioxide saved per ton of recyclable material used. 4 ton of CO2 saved per ton of recyclable material used. 20 tons CO2 saved of per ton of recyclable material used. And what is the additional cost of creating or of producing this recycled material? Plus $150 per ton, plus 200 per ton, plus 1,000 per ton. Right? To see, this is the data given to you. What will you do? Right. First of all, can you tell me what is the maximum carbon dioxide saving possible for each material? By looking at data, and you can put it in the chat or just think about it and tell me how much is the maximum CO2 saving possible in aluminum, copper, and REEs respectively if you use that recycled material. So let's see. The maximum carbon dioxide saving if you use maximum capacity of aluminum, copper, and REEs recycled material would be 80,000 into 9, 80,000 into 9, 40,000 into 4, 400 into 20. 80,000 into 9 is 7,20,000 tons CO2 saved if you recycle aluminum and to its maximum capacity and use it fully. Similarly for copper, similarly for REEs. So the aluminum has the biggest emission impact so far in the absolute value, 7,20,000 ton. If you use entire 80,000 recyclable aluminum, you will save 9 tons CO2 and hence 7,20,000, which is huge as compared to copper and RE. Now, step two, let's also understand what is the incremental cost to factor. I mean, this is good that we are saving so much of CO2, but what is the additional cost associated with it? The additional cost associated with it will be this much, 80,000 into 150, 40,000 into 200, because it is the additional cost of recycled material. So maximum incremental cost, additional cost will be 80,000 into 150 if you use aluminum, or if you recycle aluminum and fully use it. Copper, if you recycle copper and fully use it. If REs, if you recycle REs, which is rare earth elements, and fully use it. So 80,000 into 150, 80,000 into 150, 40,000 into 200, 500 into 1,000. So 12 million, 8 million, and this thing. So what is the answer? In the absolute basis, REs represent the least incremental cost for recycling. But these are two different data. One is how much emission potential you have and how much cost you need. What you need to see, what is the carbon dioxide incremental cost per carbon dioxide saving? Like how much incremental cost you will incur so that you can maximize the carbon dioxide saving at the least possible cost. So let's see that. For aluminum, it is 12 million divided by 720 ton. So what we are calculating is dollar per ton saved. How much cost we are incurring per ton of carbon dioxide avoided. So aluminum, it is $12 million divided by 7,20,000. Similarly, 8 million divided by 160,000, 0.5 million and 10,000 tons. So when you do that, what you understand is the lowest cost per ton of CO2 saved, lowest cost, additional cost per ton of CO2 saved aluminum. And on the absolute basis also, you are doing huge saving, CO2 saving. So it makes sense right now to start focusing on aluminum and recycling aluminum. By the way, aluminum is something which is easily recyclable. That is one, and RE is the element, the rare earth element right now, which is most difficult to recycle. Aluminum is very easy. Aluminum and steel, they are most easiest products to recycle, right? While REs would be difficult because anyway they are used in small quantity. They are, there are so many other things. So that's the insight. So you might want to say that lowest cost per ton of CO2 saved is aluminum, so hence use it, hence recycle it, focus it on it, which is great, and you should do that. A recruiter may ask a cross question also to you. Beyond the MAT, that looks good. We should do this definitely. Beyond the MAT, what qualitative factor might still make REs also important? And that's where you need to supply security. Like REs are difficult to get. We should recycle them not from the cost perspective, but from the supply sustainability perspective. Geopolitical risk. Because of geopolitical risk, it is very difficult to get by these materials. And these are critical components in any of the, and there's a lot of competition for these materials from other industries also. So it makes sense to recycle them as well. And definitely eventually recycle everything as much as possible. Right? So these are some of the cross questions you can consider. So last step is recommendation. Whatever you have done, just give a recommendation like prioritized based on our data. Prioritize recycled aluminum first due to its largest emission reduction potential, meaningful supply volumes, and lowest cost per ton of how much? Of $17 per ton as compared to 50 per ton. So definitely do that. Prioritize aluminum. Develop copper as a second focus area, while in the long term, definitely work on REs also. Also take a long-term strategic approach to rare earth element, investing in R&D and partnership now despite limited near-term volumes, right? Because they are very, very strategic in nature. Support all three through ecosystem actions such as product design for recycling, long-term offtake agreement, and partnership with recycler and policymakers. These are some of the recommendations you may want to give. So with this, we end the cycle of our case, and this was very interesting case, very, very current case and very, very current problem which lot of companies are solving. So it is good idea to have this perspective to you. You can go through this video again to understand more, right? By the way, this company, as I told you, right, this company, can you guess which company is it? Can you give me your name? What company will it be? Could it be? It's a global consumer electronics company which wanted to recycle some of its material. What company it is? Okay. So this company is, and I'm giving you the real case. So I have used a lot of fictitious data and everything, but you can read the real case. And this case is Apple, right? This is the real case of Apple, which worked with McKinsey to find out how to recycle, how to increase the recycle percentage in their product to ensure supply security, to reduce carbon dioxide emissions, and have strategic benefits in future, right? So you can go through there, right, in this case study, right? So we end the session today. These are the framework you should use to distinguish it. Just to summarize it, listen carefully, paraphrase your understanding, do not jump to solve the problem, show your approach, take interviews hint, think aloud. It is okay to get stuck, do not give up. And then these are the usual resources, you can go through them. We also do one-to-one mentoring, career guidance, resume reviews, mock interview. If anyone is interested, you can visit our website or you can contact us. And we have a lot of smart kits on guesstimate, consulting and guesstimate bundle, consulting case studies, product management case studies. You can go through our website through these links and you can consider it if it is helpful to you. Thank you so much. Keep in touch. I will see you next time. Thank you so much.